So today we have a very beautiful geometrical problem. This particular geometrical problem originally belongs to Sir Michael Penn's YouTube channel. He already made a video on this particular problem, and the reason I am making the video on the same problem is I have a different approach. So the question is like this way: we take a rectangle ABCD. Now taking AB as the diameter, we draw a semicircle outside this rectangle. Now we mark a point P on the circumference of the semicircle. Now we draw two line segments joining the points PC and PD. Now we can see that the line segment PC and PD are meeting the line segment AB, so let that intersection point be X and Y respectively. So this was all about the diagram. Now it has been given that if 2 times BC square is equals to AB square, then prove that AX square plus BY square is equals to AB square. So this is the thing that we need to prove, and Sir Michael Penn used the coordinate geometrical approach to this problem, and I am going to use a plane geometrical approach. So this is Anmol, and now let us see the solution. How can we solve this problem? Okay, now let us start with the solution. So the first thing that we are going to do is we are going to take the side length AB of the rectangle and mark the center of this side length. Now the point to be noted over here is that if I will mark the center of this line segment AB as the point O, this particular point will also be the center for the semicircle, and the reason this is happening is because AB is the diameter for the semicircle. Okay. Now what I will do is I will simply drop a perpendicular from the center point O to the base of this rectangle. Okay. Now look carefully, as I have dropped a perpendicular, this angle would be 90 degree. Now look carefully, as we saw, the length of AO is equals to the length of BO, and this thing is equals to the length of AB upon 2. Now it is already given that the length of this rectangle is having a length B, therefore this thing is ultimately equals to B upon 2. And as we have seen that this particular quadrilateral and this particular quadrilaterals are rectangle, therefore the length of AO would be equals to, let this particular point where we have dropped the perpendicular be named as the point M. So the length of AO would be equals to the length of DM, and this thing would be equals to B upon 2. Similarly, the length of BO would be equals to the length of CM, and this thing would also be equals to B upon 2. Okay, so therefore the length from D to M is equals to B upon 2, and the length from the point M to C is also equals to B upon 2. Okay, now look carefully at this point P that is present on the circumference of the semicircle. Now what I will do is I will simply drop a perpendicular from this particular point P to the base of this rectangle. So this particular angle that has been formed over here would be 90 degree, as we have dropped a perpendicular. This particular quadrilateral was a rectangle, hence this side would be parallel to this side. So according to the corresponding angles, if this angle is 90 degree, this means that this particular angle would also be equals to 90 degree. Okay, and similarly we can say that if this angle is equals to theta, this angle would also be equals to theta, because these two lines are parallel to each other. Similarly, we can mark one more angle, that is, this angle is equals to alpha. This means this angle would also be equals to alpha, and this is happening because the side AB is parallel to the side DC. Okay, and this property is known as the corresponding angles. Now what I will do is I will mark some of the length. So the length from this point where the center was there, let this point be O. So the length from O to X, I will take it as a variable small x, and the length from Y to O, I will take it as a variable small y. Okay, now look carefully. The length from A to O is equals to B upon 2. Let me write that thing. So the length from A to O is equals to B upon 2. The length from O to X we have taken as a variable small x. So if I just add these two lengths, I will get AO plus OX, and according to the diagram, that thing will ultimately form AX, and that would be equals to B upon 2 plus X. Okay, keep this thing as the equation number 1. Now look carefully, according to this particular diagram, the length of BO is equals to B upon 2, and the length from O to Y we have taken as a variable small y. So the length from O to Y is equals to small y, and if I will just add these two lengths, I will get BO plus OY, that is equals to BY, and that is going to be equals to B upon 2 plus Y. So let that be equation number 2. Okay, and here we have got the equation number 1. Now look carefully, the question is to prove AX square plus BY square is equals to AB square. So just now we have got the value of AX and BY, so we can just plug in this value in the LHS of this particular equation. So in the left hand side we can see that we required AX square plus BY square. Now from the equation number 1, the value of AX square would turn out to be B upon 2 plus x the whole square, and according to the equation number 2, the value of by is going to be b upon 2 plus y, and therefore b upon 2 plus y the whole square will be the value for by the complete square. Now opening the bracket and simplifying this thing will give me b square upon 4 plus x square plus bx. This is the value for the first bracket, and the value for the second bracket will turn out to be plus b square upon 4 plus y square and plus by. Now if I will just simplify the like terms, so first of all b square upon 4 plus b square upon 4 will turn out to be b square upon 2 plus, now we can just make a pair of bx and by. We can just take b common, so inside the bracket we will have x plus y, and at the end plus x square plus y square as it is. So this is the value of the left hand side, and we need to prove that this thing is equals to right hand side. So the value of right hand side is ab square. The value of ab is equals to small b, therefore ab the whole square will become b square. So ultimately we need to prove that the value of b square upon 2 plus this thing is equals to b square. Okay, so by keeping this thing in our mind, let us move back to this diagram. So now what I will do is I will just take this particular length that is from this perpendicular to the point O as a variable z. Okay, now look carefully, this particular quadrilateral is also a rectangle because all the 4 angles will turn out to be 90 degree. Hence the length from the point M to this perpendicular would also be equals to z. Okay, this length would be equals to z. Now look carefully, the length from the point D to M is equals to b upon 2. The length from this perpendicular to the point M is equals to z. Therefore the remaining length, let me change the color, let it equals to yellow. So the remaining length that is from the point D to this perpendicular will turn out to be the longer length minus the shorter length, and finally it will turn out to be b upon 2 minus z. Okay, now similarly the length from this point M to C is equals to b upon 2, and the length from this point M to this perpendicular is equals to z. Therefore the complete length from this perpendicular to the point C will turn out to be b upon 2 plus z. So the length from this perpendicular to this point will turn out to be b upon 2 plus z. Okay, now what I will do is I will mark one more length inside this diagram. So the length from the point P to this perpendicular, I will take it as a variable h. Now as we have taken the length from the point O to this perpendicular as equals to z, we can mark some more lengths. The length from O to y was equals to small y, and the length from O to this perpendicular is equals to z. Therefore the remaining length that is going to be from the point y to this perpendicular will turn out to be the longer length minus the shorter length, and therefore it will turn out to be y minus z. Still keep this thing in your mind that the length from O to y was taken as small y. Okay, the length from the point O to x was taken as small x. The length from O to this perpendicular is equals to z. Therefore the complete length that is going to be from the perpendicular to the point x will turn out to be simply z plus x. Okay, and still keep this thing in your mind that the length from O to x was taken as small x, and the length between these two perpendicular was taken as a variable z. Now what can you say about the length of this particular line segment that is from this perpendicular to this perpendicular? Look carefully, this particular quadrilateral will turn out to be a rectangle because all the 4 angles are 90 degree, and therefore the length of this line would be equals to this line. The length AD is the height of the original rectangle ABCD having a length small a. Therefore the length from this perpendicular to this perpendicular would also be equals to a. Okay, now what I am thinking is to just redraw some of the things outside the diagram so it is clear to explain. So first of all, let me just draw the triangle, that is the triangle DPC. So here's the triangle, let me draw it clearly. So the triangle is like this way, and then we have the perpendicular, and there's a straight line like this way. Now first of all, these angles are 90 degree, there is no doubt in that thing. These two angles we have got as theta and theta. These two angles we have taken as alpha and alpha. The length from here to here we have got as b upon 2 plus z. I will just show you the original diagram. The length from here to here we have got as b upon 2 minus z. This length we have got as x plus z. This length we have got as y minus z. The length from here to here we have taken as equals to h, and the length from this point to this point we have just got as a variable small a. Now just cross check with this original triangle. The triangle we have taken is PDC. Here is the triangle in the diagram. So now look carefully in this smaller right angle triangle. The value of tangent of theta will turn out to be height, that is h, upon the base, that is y minus z. And according to this bigger right angle triangle, the value of tangent of theta will turn out to be, the length of the complete height would turn out to be h plus a. So h plus a upon the base, that is b upon 2 minus z. Now in these two equations we can see that they are ultimately equals to tangent of theta, hence we can compare their right hand side. So h upon y minus z would be equals to h plus a upon b by 2 minus z. B by 2 minus z can be just simplified and written as b minus 2z, and the 2 will go as a multiplication on the top. Okay, now similarly we can see that this right angle triangle and this right angle triangle is similar to each other because of 90 degree, 90 degree, and the angle alpha being equals to each other. Okay, so again we will do the same things, and the ratio that we will get now would turn out to be like this way: h upon x plus z is equals to 2 times h plus a divided by b plus 2 times z. Okay, so I've taken this first equation and I'm doing the cross multiplication, that is b minus 2z multiplied over there and y minus z multiplied over there. So I will get bh minus 2hz equals to 2hy plus 2 times ay minus 2 times hz and minus 2 times az. Okay, now if I do the cross multiplication in this equation, I will get bh plus 2hz equals to 2hx plus 2ax. Okay, and then I will get plus 2hz plus 2az. Okay, so these are the two equations that I have got by doing the cross multiplication. Now what I will do is I will just simply add these two equations. Minus 2 times the product of h and z plus 2 times the product of h and z got cancelled out. What is remaining is 2 times bh, and this thing equals to, now we can again see that negative 2hz, positive 2hz, negative az, positive az got cancelled out, and what is remaining is 2 times hx plus 2 times hy plus 2 times ax plus 2 times ay. The 2 can be factored out, and if I will just isolate h on one of the side, I will get h is equals to a multiplied with x plus y, this thing divided by b minus x plus y. Okay, so this is the value of h in terms of a, b, x and y. So keep this equation as it is, and this is the important equation, so I'm just marking it as important. Okay, now let us move back to these equations again. So what we have just got is the value of h in terms of a, b, x and y. Now we are considering this thing as the important variables. So we have already got the value of one of the least important variable in terms of the important variable. Now make a guess of the second least important variable, and that is z. So now our goal is to get the value of z in terms of these variables. Just take these two equations again. So now what I will do is I will keep h over here and bring down 2 times h plus a in the denominator. So now this fraction will look like h upon 2 times h plus a is equals to y minus z upon b minus 2z. And similarly in this one also I will do the same thing. I will bring this over here and that over there. So I will get h upon 2 times h plus a is equals to x plus z upon b plus 2 times z. So we can see that the left hand side of both of these fractions are equal, hence we can compare their right hand side. So y minus z upon b minus 2z would be equals to x plus z upon b plus 2z. So now we are going to do the cross multiplication over here. So we will get by plus 2 times zy minus bz minus 2z square equals to x times b plus z times b minus 2zx minus 2z square. So minus 2z square get cancelled out. Now I will just try to isolate z on one of this side. So let me just remove these terms. So now I can see that z is present in this one, in this one, in this particular term and in this particular term. So first of all on the other side I will get xb minus by. I can take b common. So inside the bracket I will have x minus y and this thing divided by. So now if I am just taking these two terms together and moving these two terms on the other side and taking z common, so what is going to remain in the denominator is taken common, and inside the bracket we can write y minus b plus x. Okay, now we can take the negative sign common from the numerator and denominator and cancel them out. So at the end we will get b multiplied with y minus x divided by 2 times b minus x plus y. Okay, so b minus x plus y, this is the value of z. So the first important equation that we have got was the value of h, that is over here. Now we have got the value of z, and that is going to be b multiplied with y minus x divided by b minus y plus x, and all of this thing multiplied with 2. This is the value of z in terms of b, x and y. Okay, now let us utilize this thing very nicely. So now look carefully in the diagram. The only thing that we have not utilized till now is the presence of this semicircle. So let me just remove these things from here. Okay, so everything would be clear. Now recall that we have just dropped a perpendicular like this way, and that length we have taken as equals to h. Here was the point O, and the length from this point O to this perpendicular was equals to z. Now what if I will draw a line segment from the point O to the point P? It will ultimately turn out to be the radius of the semicircle, a line segment from the center to the circumference. The diameter of this semicircle was equals to B, therefore the radius would be equals to B upon 2. So now we can see that here we have a very nice right angle triangle. Therefore by Pythagoras theorem, height square plus the base square is equals to hypotenuse square. So now we can just put the values of h and z in this particular equation that we have got over here. So h square will turn out to be a square multiplied with x plus y the whole square, this thing divided by b minus x plus y, and this thing also complete square. This thing added with the square of z, so that thing will turn out to be b square multiplied with y minus x the whole square divided by b minus x plus y, this thing the whole square, and don't forget this 2 in the denominator, so the square of 2 will become 4, and this thing equals to b upon 2 the whole square, that would be b square upon 4. Now as we have till now not utilized the fact that we have a semicircle, we have not utilized this fact also, that is 2 times a square is equals to b square. So if 2 times a square is equals to b square, so I have just written this thing 2 times, let me just write this thing again. So as we have this given data that 2 times a square is equals to b square, we can just write a square as equals to b square upon 2. So this a square we can just replace it as b square upon 2. So b square upon 2. Now look carefully, from this whole equation I can just factor out this b square and multiply 4 in this whole equation. So first of all, if I will multiply 4 over here, from the table of 2 it will become 2. So 2 times x plus y the whole square, and at the same moment I will just take this common denominator of b minus x plus y the whole square on the other side. So this thing will get simplified very nicely, and at the end we will have 2 times x plus y the whole square plus y minus x the whole square equals to b minus x plus y, and this thing the whole square. What I have done is, first of all I have multiplied 4 in this whole equation, and then I have just taken this common denominator on the other side. Now I will just open this thing as by taking this as one term and this as the other term. So this thing will turn out to be like this way: b square plus x plus y the whole square plus, not plus, minus 2 times b times x plus y. Now look carefully, 2 times x plus y the whole square, I will just move this term on the other side. This thing will turn out to be only single times x plus y the whole square, and this thing will get removed from here. Now I will open these two brackets and just simplify them. So first of all, this bracket will give me x square plus y square plus 2xy, and this bracket will give me plus y square plus x square minus 2xy, and this thing equals to, now this side we have remaining with b square minus 2 times b times x plus y. Now plus 2bx minus 2bx got cancel out, x square plus x square 2x square, y square plus y square 2y square, and I will just divide 2 in this whole equation at the same moment and bring this term on the other side. So finally we will have x square plus y square. The 2 will get removed from this term, and as we are shifting it from that side to this side, plus b times x plus y, and this thing equals to b square, and as we have divided 2, this thing upon 2. So the value of x square plus y square plus b multiplied with x plus y we have got as equals to b square upon 2. Now look carefully in this equation that we have got by simplifying the left hand side, the written in the blue color. This particular term that is present over here, the value of this thing we have just got as b square upon 2. So if I will just replace this remaining things as equals to b square upon 2, let me change the color with the blue one, with b square upon 2. So b square upon 2 plus b square upon 2 will become b square, and that is ultimately equals to the right hand side, and hence we have proved what was required. So this was my way to prove this particular thing. If you have any other method other than mine or Sir Michael Pence, you can do comment below, or else if you want to share any kind of picture you can email me, or else you can send it to me on my Instagram. The link is in the description.